Right, the International A-Level P for October 2021 question 5 is parametric equations here with trig functions and a restricted domain. You can give you a little drawing of the C as well. So use parametric differentiation to find the gradient of C when x is equal to 3. It's tempting to look at this and think, oh, I can get a Cartesian here because I've got sec squared. I can get what tan squared is and use sec squared is 1 plus tan squared. But it specifically says use parametric differentiation, so I'll have to do that. Find the gradient when x is equal to 3. Then it says find f of x in that form. So that's when we use the trig identity to get the Cartesian form, and then we've got to find the range of f. So I'm going to a little bit of the graph to start off with. I'll find where the ends are by subbing in these end values. So when t is minus pi over 3, I get this. Tan of pi over 3 is root 3. I've got minus it, so it's 5 minus 2 root 3, which is about 1.5. The y value, well, cos of pi over 3 is a half, so the sec of it is 2. Minus pi over 3 will still be the same because of the symmetry of the cos function. So 8 times 4, which is 32. The pi over 4, second pi over tan pi over 4 is just 1. So that just gives me 7 down here. Now that's the larger of the x values. So this one at the top is this x value, and y value 32, and the x value at this end here is 7, and the y value, the cos of pi over 4 is 1 over root 2, so the sec is just root 2, and the square root, I get 2, so the y value there is 16. Right, so use parametric differentiation to find the gradient, dy by dx, the y differentiate in terms of t over the x differentiate in terms of t. The y, well, 2 will go in front, so it's going to be 16 because it's something squared, and then sec t to the power of 1. Multiply by that sec t differentiated, which is in the formula book, sec t tan t. The x differentiated is just going to be 2 sec squared t. That's in the formula book as well. We'll do a bit of cancelling. We've got sec squared on the bottom and sec squared on the top. So I'll just have 8 tan t. It tells me I'm going to find the gradient when x is 3. So I'll find out what the t is when x is equal to 3. By writing 3 was 5 plus 2 tan t. Give me tan t is minus 1. So the t is minus pi over 4. Putting that into here, I get minus 8. But you could have just looked at this and thought, right, 8 tan t. Well, I can sort of get that from here. I can write x minus 5 multiplied by 4 is going to be 8 tan t. So I can actually get the dy by dx in terms of x, which is what I want really. Now I want to put 3 into here. I get 4 times minus 2, which gives me that minus 8. And then part B, this is where we're going to use the trig identity to get the Cartesian form. So I use sec squared is 1 plus tan squared. It's tempting to write sec squared is y over 8. What I'm going to do though, I'm going to multiply this all by 8, and then I'll have 8 sec squared t here. Save me getting some fractions involved. And then I just need 8 tan squared t. Well, if I rearrange this, I'll have 2 tan t is x minus 5. If I square it, so I've got tan squared, I'll have 4 tan squared t is x minus 5 squared. And then I can double both sides then to get 8 tan squared is equal to 2 times that bracket. And then I can replace the 8 sec squared t with y, the 8 tan squared t with this, and then we've got an extra plus 8 on the end. Now, the way even when you do part A, if you'd have done this in part A and got the Cartesian form and then differentiate, you wouldn't have got any marks in part A, which is a bit of a shame, but it specifically says use parametric differentiation in part A. So you can't sort of get this Cartesian form and then do dy by dx from this. What you could do though, this minimum point then is, which I'm going to need in a moment, is when x is 5 and y is 8. What you could do, though, we found out that dy by dx is 4 times x minus 5. Remember, it was 8 tan t, the dy by dx. We can just integrate this because we've got y in terms dy by dx in terms of x. So if x minus 5 all squared over 2 and multiplied by 4 and put plus c on the end. So the y then is 2 times x minus 5 squared, and we're nearly there then. We just need that plus c, and we can get that by putting 7 over 16 in. You can put this one in, which we found before as well. So putting 7 and 16 in, I get this. The y is 16, the x is 7, giving me that c is equal to 8, which is what I had before. Then it wants finally wants the range of f. So all these y values, I've got the minimum y value here and the maximum. Incidentally, this function, this c, if it asks you for the domain of it, well, here it is. I found the ends, the x value, the minimum x value, and the maximum x value. That's the domain of f of x. But we want the range, it says, which is anything between 32 and 8 inclusive.